7-2, multiplying powers with the same base. Objective, to multiply powers with the same base. Solve it. Scientists estimate that there are about 10 to the 20th power stars in the universe. A cubic meter of beach sand contains about 10 to the 9th power grains of sand. Suppose all of the sand from the world's beaches is combined into one large beach, as shown below. Are there more stars in the universe or grains of sand on the world's beaches? Explain your reasoning. All of the numbers in the solve it are powers of 10. In this lesson, you will learn a method for multiplying powers that have the same base. Essential understanding. You can use the property of exponents to multiply powers with the same base. You can write the product of the power with the same base, such as 3 to the 4th power times 3 to the 2nd power, using one exponent. So here we have 3 to the 4th, 1, 2, 3, 4. 4 3's being multiplied. And we have 3 to the 2nd power, and there's my other 2 3's. And that is equal to 3 to the 6th power. Notice that the sum of the exponents in the expression 3 to the 4th times 3 to the 2nd, so the exponents are 4 and 2, equals the exponent of 3 to the 6th. So they're pointing out that 4 plus 2 is 6. We're only looking at the exponents, since the base is the same. In general, an equation such as 3 to the 4th times 3 to the 2nd is 3 to the 6th can be written using variables. So now we're just going to throw letters in there because it doesn't matter what the numbers are. It works for everybody. As long as we have the same base, we can take the exponent m and add it to n. So you can see how much shorter 3 to the 6th is than writing all of this out, or even writing these two out. Here's why it works. You can use repeated multiplication to rewrite a product of powers. So we have a to the m times a to the n, and so we have these dots in here because we're saying it doesn't really matter how many's inside here or inside here. It just means that when we put them together, we're going to add our exponents together. Problem number 1, multiplying powers. What is each expression written using each base only once? So we have 12 to the 4th and 12 to the 3rd, and we add them together, so we have 12 to the 7th, and so we simplified the exponent. So in B, we have -5, but our exponents are -2 and 7. So we have -2 plus 7. That's what we do with our exponents. And you see our base stays the same. And then -2 plus 7 is 5. When variable factors have more than one base, be careful to combine only those powers with the same base. Problem 2, multiplying powers in algebraic expressions. What is the simplified form of each expression? So here we have 4z to the 5th times 9z to the -12. So we can multiply 4 times 9, there's our 36, and then we have z, and our exponents are 5 plus a -12. So on the z is what the exponent is going with, and it's at a -7. So that -7 only has to do with the z, so that's getting pushed to the bottom of the fraction bar line because it's a negative, and it stays z7. So if we look here at problem B, we have 2a times 9b to the 4th power times 3a to the 2nd power. Well, we can pull out our like numbers. So 2 times 9 times 3 we have right here. So the shortcut would be 2 times 3 is 6 times 9, and there's our 54 showing up down here. And then we look how many a's we have. We have 1 right here, the exponent, there isn't any, so it's understood as 1. And here we have 2 more. So we have 1 plus 2 is 3. And then we realize we only have 1b, but it has an exponent of 4. So b to the 4th power just gets carried along to the answer. You can use the property for multiplying powers with the same base to multiply two numbers written in scientific notation. Recall that you can use the power of 10 to make writing very large or very small numbers more convenient. In scientific notation, you can write any number as a times 10 to the b, where you see a has to be positive and between 1 and 10. Remember, the decimal is always right behind that first number, so it has to be less than 10. It can be 1, but it can be anything between those two. For example, 256,000 is written in scientific notation. There's our decimal behind the first number that's not 0. 2.56, 2 and 56 hundredths times 10 to the 5th power. So we had moved the decimal 1, 2, 3, 4, 5 times to get behind that 2. So we have an exponent of 5. Problem 3, multiplying with scientific notation. In chemistry, here's an example of a problem you'd find there. At 20 degrees Celsius, 1 cubic meter of water has a mass of about 9 and 98 hundredths times 10 to the 5th power grams. Each gram of water contains about 3 and 34 hundredths times 10 to the 22nd molecules of water. About how many molecules of water does the droplet of water shown below contain? So we look at molecules of water where we start out with cubic meters. To get rid of cubic meters, we need to multiply to a fraction where grams is equal to cubic meters. So we push the cubic meters into the denominator, so these two cancel out. But we change our grams, then we need to change it to molecules, so we make a fraction with grams on the bottom that's equal to molecules on the top. So now our grams cancel out and we're at molecules. So here we have 1 and 13 hundredths times 10 to the negative 7 times 9 and 98 hundredths times 10 to the 5th power. And we have 3 and 34 hundredths times 10 to the 22nd power. So here we take to look and see why we're doing this. So if we come back here, 1 droplet in cubic meters is 1 and 13 hundredths times 10 to the negative 7. And then the next one is where we canceled out the cubic meters and we're changing it over to grams. And they tell us that right here, that the mass is about this much grams. And they're saying 1 cubic meter of water. So the cubic meter of water is down here, and we're multiplying that to 9 and 98 hundredths times 10 to the 5th power. That's our grams on the top. So there's a 1 underneath here, but we can see those got canceled out. Next, we're going to look at the 3 and 34 hundredths, and it says each gram of water contains about this much molecules. So 1 gram of water has this much molecules. So again, the grams got canceled out because there's a 1 underneath here for the grams. And so we just substituted in each of these. So we can take these numbers here and multiply them. So put it in the calculator. And then here we have the same base of 10, so we take the negative 7 plus 5 plus 22, and we end up at 20. The droplet contains about 3 and 77 hundredths times 10 to the 21st molecule of water. Exponents can also be expressed as fractions. Fractional exponents are called rational exponents. Recall that 3 squared means 3 times 3, which equals 9. We can write the same expression using rational numbers. 9 to the 1/2. The equation 9 to the 1/2 is equal to b, indicates that b is a positive number that when multiplied by itself equals 9. So if we have 9 to the 1/2 is equal to 3, and since 3 times 3 equals 9, in general, the 1 to the m is equal to b. It means that b is multiplied as a factor m times equals a. So this 2 here says you can take 3 times 3 to get to 9. So if you take the exponent 2 here and move it over to the 9 because you want to go backwards, then it's half, 1 over 2. Problem 4, simplify expressions with rational exponents. Simplify all expressions 81 to the 1 power 1/4. So we have 81 to the power 1/4. So we need to take one number that's multiplied 4 times to equal 81. We have 9 times 9, which is 2 of them, and both of those break out down to 3s. So here, 81 to the 1/4 is equal to 3. So we know that 3 times 3 times 3 times 3 equals 81. Problem number 5, simplifying expressions with rational exponents. Simplify an expression 64 to 3/2. So we know 3/2 is equal to 1/2 plus 1/2 plus 1/2. And so when we take the square root of 64, we have 8. So 8 times 8 times 8 is 512. You can use the properties of multiplying powers with the same base to simplify expressions with rational exponents. Here's our property. Multiplying powers with the same base. Words. To multiply powers with the same base, add the exponents. So we know we're going to do m plus n as long as a is not equal to 0. And m and n are rational numbers. An example, 4 to the 1/3 plus 4 to the 1/3. So we add those 1/3 together and we get 2/3. Here we have b to the 7th times b to the -4th. So 7 plus -4 is 3. So we have b to the 3rd power. Problem 6. Simplifying expressions with rational exponents. Simplify the expression 2 and a to the power of 2/3 times 3 times b to the power of 1/4. This is multiplication. And then we have a to the power of 1/3 times 5 times b to the power of 1/2. And so we pull out 2 times 3 times 5. That's the easy part. 2 times 3 is 6 times 5 is 30. All right, then we notice that, okay, so we have a to the 2/3, a to the 1/3, so we put those two together. Then we have b to the 1/4 and b to the 1/2, and we put those two together. All right, so then we're going to look at our variable a. We have 2/3 plus 1/3 is 3/3, which is just 1. Then we look at our variable b, and we have 1/4 plus 1/2. 1/2, we get that to a common denominator of 4 is 2/4. So this is 2/4 plus 1/4 is 3/4. So b to the 3/4. So you need to watch it really closely to see what's going on here. They're not going to tell you in the instructions how to get a common denominator before you add them together, because you should already know that.